Welcome. This video we're going to look at an ice chart type problem here, and we've got an equilibrium scenario given, and our first question is write the K expression for this reaction. Notice that it is a Kp that I'm being asked for, so I want to make sure I use the appropriate symbols here. And when I write a K expression in general, it's products over reactants, so my CO is going to go on the top, but instead of writing square brackets CO, that would indicate concentration. What I want to do is I want to show pressure. So I'm going to say pressure of CO, and I'm going to square it. And on the bottom, I'm going to have my pressure of my CO2, and then, and then I'm going to leave out my solid carbon because we leave solids and liquids out of K expression. So this is my K expression right here. It's just my two gases that I'm going to be concerned with. And then I'm given some information and I'm asked to find the value of K. So whenever I'm given some numbers and it's an equilibrium scenario, an ice chart is usually useful to kind of help organize my information. All right, so what it tells me is initially, the gas pressure in the container is 4 atmospheres. Okay, so now I got to make sure I go back and read the scenario carefully, because which gas are we talking about? I have two different possible gases. So now I'm going to go back here and make sure I read through this scenario. Solid carbon and carbon dioxide gas are placed in a container. Aha, so that means that I am starting with pure solid carbon, which we can ignore because it's not part of our K expression. And then the only gas I have initially is carbon dioxide. So when we say the initial gas pressure is 4 atmospheres, that means the pressure of CO2 is 4 atmospheres. So just got to make sure we read the setup carefully so we can figure out what's what. Okay, and I'm starting with pure CO2, no carbon monoxide initially. So that's going to be 0. And then at equilibrium, the partial pressure of CO2 is found to be 2.32 atmospheres. 2.32. So this is all we know. We know we start with 4 atmospheres of CO2 and no carbon monoxide. And at equilibrium, we have 2.32 atmospheres of CO2. So if we know equilibrium and initial, we can figure out the change because we know initial plus change gives us equilibrium. So I'm going to do a little subtracting. 4 minus 2.32 is 1.68. So it looks like our change here on that side was negative 1.68. And we know that the change row is going to match our mole ratios in our chemical equation. So we know that if we use up 1.68 reactant, I'm going to make double that much product because it's a 2-to-1 ratio. So I'm going to make 2 times 1.68. So that is 3.36 atmospheres. And so now I've got all my information organized, and I'm going to go back and I'm going to plug it into my K expression. So PCO at equilibrium is 3.36, my partial pressure of, and I don't forget to square it. And then my pressure of my carbon dioxide is 2.32. So then you're just going to do that and do that on my calculator real quick, 2.32, and I should end up with 4.87 and 3 sig figs. Looks reasonable based on all these values. So that would be my K value for this reaction.